Mining antennas. We've talked lots about mining, but I want to tell you the essence, the crux of mining and tunnels. Okay, where there's vehicle tunnels or things. What do you need? There's essentially three things that you need on a tunnel antenna. Gain. Gain is king, and I'll explain why. You need circular polarization. And we're doing more clever things. You'll see it coming out, but essentially, circular gives you a variety of polarizations. You can do it better, but I'll show you later when we've got the antennas to do so. And the last thing is you need low cross-section. What do I mean by that? I'll explain. Okay, gain, if you're in a tunnel, and the antenna sits here. Now, I'll explain just now why you don't want to put it there. Then anything, if you look at gain, it means a narrow beam width. Now, even the narrowest beam width will start hitting these sides, and it will go like that. And it can be proven over a little bit of distance, and for our antennas, little is about 200 meters. You lose power each time, so these beams tend to disappear, and the only ones that really remain is the one here and perhaps the one just off center. So higher gain, better. Everything else is actually wasted. Of course, can't forever get that. And I'll explain what gain works like. Circular polarization. I've explained it millions of times, but that was the biggest breakthrough when we designed an antenna in 96 in a university. Then nobody used it for 14 years, and someone tried to use it, actually an Australian company in a coal mine, and their mouths fell open. Circular polarization propagates like hell. And why does it propagate so well? And we've explained it in many videos before, but the fact is that a circular wave, for example, when it reflects, it doesn't interfere with itself, because you always get a reflection at some point, and it changes polarization. Left doesn't interfere with right. But mostly, sometimes vertical works better, sometimes horizontal works better. And of course, having circular, the one that works better will propagate longer. And if you look down a tunnel, no, that's not, normally people don't like tunnels like that. They want to walk somewhere or whatever, so it looks like that. And there's a vehicle or train or whatever in it. You find, for example, that the trains run close to the top because people don't like to waste space with tunnels. And perhaps vertical polarization will go easier. Then it will happen. You will have it happen. It works phenomenal. And then low cross-section. For antennas to increase gains, if it's an aperture antenna, so if you've got this size antenna, you want to double the gain, you double the area, and you make it bigger. Now, the problem is people don't dig tunnels to fit antennas into them. Okay, so a tunnel is used for something, and that's why I said you never put it there. You'll have to put it on the top. The way to get around this is to use end-fire antennas. Now, end-fire antenna is a long thing with not much cross-section, like our Helis, okay? And this size Heli will give you a gain of, say, 11 dB. And if you double the size of the Heli, you can get up to 3 dB more gain, so you can get 14. So you go for maximum gain within a certain range. And, of course, cross-section stays the same. This antenna stays the size. Yeah, it gets long, but a tunnel is long, so it doesn't mind long things. It minds things going this way. That is what you need. And lately, you need bandwidth. I'll explain it later.